In this video, we take a look at yet another geometry puzzle, and if you enjoy these, be sure to check out the previous ones. The link can be found in the description below. This time we consider the following scenario. We want to get a long, rigid object, for instance a ladder or a long beam, through a corridor which has a corner of 90 degrees in it. The corridor itself is 2 meters wide, and the object has double this length, so 4 meters. Now, instead of using trial and error in real life, we want to figure out beforehand whether we will be able to make it through this corridor or not. And to solve this puzzle, we need to calculate what is indeed the longest straight object that can go through this specific corridor. And as always, the best way for you to learn is to pause the video and have a go at this puzzle yourself, and then later come back and compare your results and see how it's done step by step. So let's now continue and solve this puzzle. Now, there are 3 ways that come to mind to get this object through. First, we immediately see that an object whose length is equal to the corridor's width will easily get through. However, this is quite obvious, and as you probably know, there are ways to get much longer objects through. And this brings us to the second scenario, where we would tilt our object. In this case, we can transport the object parallel to itself through the corridor, and it will indeed make it through. The limiting distance in this case, that determines the maximum length of the object that can go through the corridor, is this distance in the corner right here, which can be calculated as follows. And because this line connects 2 corners of our corridor, and the angle of this corner is 90 degrees, we can form a right-angled triangle with the distance that we're looking for, this x, as its longest side. Now we know that this side will simply be the width of the corridor, namely 2 meters. And since this angle is 45 degrees, half of 90 degrees, we know that this side will also be 2 meters. Given this information, we can now use the Pythagorean theorem to find our distance x. We simply find that x is equal to the square root of 2 squared plus 2 squared. And since 2 squared is equal to 4, we get that our distance is equal to the square root of 8. And therefore, we find that in this case, where we tilt our object 45 degrees and then transport it parallel to itself through the corridor, we get a maximum length of 2.83 meters, which is already an improvement from the previous case. However, of course, we can do even better. However, at this point, you've probably already solved the puzzle yourself by realizing that we can get an even longer object through the corridor by rotating it around the corner. And this is indeed the best way, but we still need to determine whether our 4-meter object can actually make this turn in this fashion. And to do this, we notice that the limiting distance in this scenario is this distance right here. Therefore, it is this distance that we need to calculate in order to see whether 4 meters can actually pass this corner. And to actually find this distance x, we are again going to look for triangles that we can use to calculate this distance. And here we again see that we can make a right-angled triangle right here, which is identical to the right-angled triangle that we can make here. Now we know that for both of these triangles, this side will be 2 meters and this side will be 2 meters, simply the width of the corridor. Now what we would like to know, of course, is the length of this side and the length of this side. And visually, it seems to be also 2 meters. However, let's prove this rigorously by using some simple geometry. We know that this entire angle will be 180 degrees. And since we know that this angle will be 90 degrees, simply the angle of the corridor, we subtract 90 degrees. And what remains are these 2 angles right here, and they should both add up to 90 degrees. And since both angles are equal to each other, we know that this 90 degrees that we're left with will have to be equally divided by these 2 angles. And therefore, each angle will be simply 45 degrees. And this we can use together with the fact that both of these angles are 90 degrees. We find indeed that these 2 sides of these 2 triangles are also of length 2. And now we can take this puzzle home, because for both of these triangles, we can calculate this long side right here by using the Pythagorean theorem. And for both of these triangles, this side will simply be 2 squared plus 2 squared. So simply the square root of 8. So if this side has a length of the square root of 8 meters, and this side also has the length of the square root of 8 meters, then we know, of course, that x will be equal to 2 times the square root of 8 meters. And running this through a calculator, we find that this is roughly 5.66 meters. And thus it is larger than our 4 meters of our original object. And therefore we see that our original object of 4 meters does indeed fit through this corridor. And it might surprise you that for a corridor which has a width of only 2 meters, you can still pass through a rigid object that has a length of 5.66 meters. And this already brings us to the end of this video. And if you enjoyed it, give it a thumbs up. If you want to get notified by future releases, consider subscribing. If you have any questions, leave a comment in the comment section down below. And with that, I thank you for watching, and I will see you in the next one. Bye.